And here's the inverter info. I guess that's all the details you get. Somewhere I showed before, there's some other setup stuff in here. See, inverter configuration. So you can do the settings in here via the MNGP2. And then when I first started, I was setting up the battery, configuring the battery. So here's my battery configuration settings in case anybody's interested. What I use for my lithiums: absorb 55.2, 1 hour absorb time, float should be somewhere between 53.6 and maybe 54. So right now I'm using this. I'll tweak it as I need, because I'm kind of got some wiring losses here and there, so I have to make up for that. So I'll set a little higher, a little lower as I need. And whatever. There's just some other settings here, and there's no equalize on lithium batteries, and no temperature offset. So you can see I have, and I'm not using ending amps either. Some people use them. I just set the equalize down there. Well, you can only set it as 1.1 volt higher than your absorb time or absorb voltage. So that's what I put, just in case. You see it's got 0, so it should never turn on, but in case it ever did accidentally, it'll only go up to 55.3. So now I'm going to go maybe have a look at the software and see what I can do. See if I can read this thing. Oh, I wanted to point out one other thing, because we saw it's running 1500 watts out of here. I have a water heater on, and it's really quiet. Now, the old Outback, the fans would have been running quite a bit. There's no fans running in this. I got fans, if you hear them, they're running in this thing, which I don't know why. I'll come in here, I don't heat this space, it's like 39 degrees and the fans are running on it. So don't think I'd recommend one of these, although the inverter works pretty good for 240 volts. But in retrospect, I think I would have got the big Rosie instead. But I got what I got now. So yeah, anyway, this is quiet, no fan running, it's not making any noise, it's not humming or anything. It's just making nice, quiet power. And I did get these on. I wiggled the wires up some and I snapped these on the best I could. So far so good. I have them covered up. I don't know, I guess I was complaining in part 1 about these, that you can only put them on in one position, like straight this way or straight that way, and if the wire bends down a little bit, you can't snap them on. But I made it work. So I'm not a programming whiz. I work with ChatGPT, see, and help me write the program. I kind of have to steer ChatGPT in the right directions and test everything and feedback errors. But it says to try this once I get my canbus loop working, which it is. And we'll see if it said to do this. So this is the terminal for the Raspberry Pi in another room. I'm not in the power room right now, but I'm going to do this command it said and see what happens. I don't see anything happen. So we'll try to figure out something else. This can dump command is a command that should just show all the CAN bus data. So let's try this one. There it is. So some of these are probably from the little Rosie. Now I got to figure out which ones or how to put them in the program. Okay, I asked ChatGPT something and it told me to try this, and I tried that and it gave me a whole bunch of stuff. So now it wants me to do something else. So I'm going to follow along with this. I'm going to start a new chat GPT chat, because when you have a real long one like this is, you know, I've been working on this program, it'll come in pretty slow. You start a new chat, it comes in really fast. And then I just asked it what to bring to the new chat, what information it needs. So I'm going to do that now, but it worked. I guess these are all just from the Rosie. No solar gain today. It's been pretty cloudy. Now it was raining, now it's snowing. I thought I'd show the canbus system I have. This is one end of it. This is the Raspberry Pi 5 here. And it goes to this USB to canbus adapter. It's an Inno maker. And I have it in the bag here just for, that's my case. But anyway, you see the activity there. This is the end of the canbus loop. So this has I can switch in or out a 200 kilo ohm. Is that what it is? 2K? I think so. Whatever the standard is you use for canbus, you can switch in or out that resistor to either be end of the line, or like if it's in the middle, you would switch it out. So anyway, I got it going in this cable here, and for the Midnite, I don't know if I said, you know, the pin out. You use 4 and 5, and I have the ground hooked up on this too. Anyway, it goes from here all the way over to, it's going over to here onto the little Rosie. And that's this one here going in, and I'm using the canbus terminals inside the little Rosie. I don't know if you can see them. I was able to get them stuck in there on that block there. So I got the ground and the high and low in there. And then this dip switch here is for, you can see, it says the CAN terminal. Since this is in the middle of the loop now, I have that switched off, so it doesn't have the resistor in it. Anyway, and then I'm using the jack here, the other canbus jack. This one's on that terminal dock. This other one is coming out of the bottom. It's like a regular Ethernet jack, and it goes to, where is it going? Okay, the one I got coming over from the Pi goes into this jack, and then this one here, the terminal one, is coming out on this yellow cable here, and it goes up into the Hawkes Bay, and it goes to here. And then this one here would go to the NGP, which right now I have remoted. So it's going, this cable's going out about, 20 or 30 feet into the other room, so I can monitor it where I usually have my computer. I'm working, so usually it'd be here. And so the MNGP2 has the terminal resistor in it, because that's the other end of the line. So so this is in the middle, and this is kind of the middle, and the MNGP is going to be the end of the line. So that explains it. And everything's working. I'll go show my software setup. Okay, here I am in Command Central with all the computer stuff. This is Home Assistant. You can see here I have the Hawkes Bay data coming in, and I think little Rosie's on this. We'll have another page here, another dashboard I made for the little Rosie somewhere here. You can see how cloudy it is. I'm not making cloudy and snow covered. Not making much of any power today. This is the Hawkes Bay. This is the Classic. And this is the Victron. Has a couple arrays on it. Classic has some arrays. These two aren't hooked up right now. And these are my big jack, or my big MB31 batteries. This SoC is off. I haven't gotten that calibrated right. It's a little annoying. But I use, where is it? I use the Victron. This is the point of truth right here, the Victron Smart Shunt, because it sees all the batteries. So this is what I go by for I want to know a real accurate SoC. That's it for all my batteries. And yeah, I made a dashboard here, inverters, just to test out. This is the one, this is the data from the Rosie inverter, the little Rosie inverter. There it is. This one I could take off, but here's the power out. I'm not taking too much power out of it now. I could turn something on and you'd see it jump up. But anyway, here's the data from that. And what I got to do when I developed the software was you go on the AI, and this is the last bit I just did today. This is some of the code. It's Python code running on that Raspberry Pi, and I had something happening where over in here, this was going 0 and then show the watts and then 0, and see how fast this one's updating. This one's going real slow because they do, all the raw data comes in real fast, but the program or the Victron or whoever, they do averaging so that it's not flipping around all the time. And anyway, here's the MNGP2 I have. And I was talking in the last video about how this is the end of the line. So here's the CAN bus coming in from over in the other room, and this is the Midnite gives us with this. It's these are the end resistors. There's a resistor in here somewhere, and that provides the end resistance that you need for the CAN bus loop. So yeah, you can see, you know, I got the inverter info here. This says 30 watts. I gotta go back to the other page and we'll see if it agrees. And this says 33 watts. This says 29 watts. It'll probably update here. But so I don't get so much MQTT data, you know, filling up the memory and the Pi. You don't want it coming in too fast. And that was some of the code I had to do, was throttling, like throttling in so you don't get a huge stream. And this stuff here was to get rid of that 0 when it would flip back to 0. And I just asked this is the Google Gemini AI. I just ask it, you know, say I got a problem, or if I have an error, I report back. It gives me the code. And then I go over, I'm learning some of these new tricks to do. I go here, this is Notepad, and on this side, this is hooked up to my Raspberry Pi here. This is the Python program right here. And then I click it and it brings it over here on this screen. So there's other ways to do it, but I just started doing this. It would have saved a lot of time if I had done this from the beginning, because I would have to go back to SSH into the, where is that at? I'd have to go here into the terminal program and SSH into it and then make changes and then restart it. And I could have done it all right here a lot easier, like right here. So anyway, I put the new code in, then I save it, and then this is all the code. This is the code for that whole program that's getting it from the Hawkes Bay and everything. So I can sort of understand what all this is, you know. But I never could have written this stuff. It explains every step of the way when you're writing it. The AI does. So it did all this kind of rounding and smoothing and stuff like that. The publishing, there's all these different, I can tweak some of these settings to have it go faster or slower. But that's pretty much it. I mean, Home Assistant is a whole nother, it's a whole nother thing. Home Assistant is here, this Home Assistant, and I don't know, that's a whole nother topic to explain how this program works, but you can make these graphics, like this screen here shows all my different kind of inverters, and you can customize all this, and you can go into the file editor and make it, have it write new things. It's too much to go into now, but anyway, it all works. And I monitor a lot of stuff on Home Assistant, like my water heater here, which is off right now, and my refrigeration. I got all that here. These are heaters that keep it warm in the winter because they're outside and unplugged, just have vegetable storage. Anyway, it's a nice program. And I have my, here's my newest batteries. They're big, like 300 amp hour batteries. And these are JK BMSs. And if I go to the old method, Jacopers, I was getting those in Grafana here. And I haven't integrated this over to, I can get the history here, whatever I want. Let's get the last 12 hours. So I can see all my batteries here, and I made all these graphics. This shows all 16 cells. They're all real tight now, but they'd be more spread out. And then I can see the differential on them all. Since they're not charging at the top, they're all pretty close. Anyway, I customized this. I got the temperatures, and so I can get all my data. Here's the voltage and the charge, discharge. It's just been discharging today for the most part because it's too cloudy or overcast. So anyway, I guess that's a good overview of how I do this stuff, or how I've written the program and how I save it, how I got the Pi in the other room, and I got this here. You know, I have it kind of all networked together. So I hope that helps someone understand and how the canbus and the program all works. Okay, one final thing is I have what's called IoT stack in the Raspberry Pi 5. So it's a Docker. It's like a Docker program. All the programs are in containers, and I know that might not mean a lot, but so this is the command line of that Raspberry Pi, and then this thing is called IoT stack. It gives you all these commands. And you can, what it does, what the beauty of it is you can choose whichever of these programs you want to build. You can just tag it and it will install them automatically and get all its dependencies and all that stuff. It makes it really easy. So the ones that are checked, I have Grafana and Influx and a few others in here. And then it'll keep them all up to date and everything. So, and then you can, it has all the commands for Docker containers. See, you can do all these things. Kind of automates it all instead of having to do it all on the command line. Like here, if I want to restart the stack, I just click this and it shuts everything down, and then it restarts it, kind of rebuilds if there's changes. So that's kind of nice. Here's one of the programs I have running on the Raspberry Pi. This is called Portainer. It's kind of an overview of everything, all these things that IoT Stack has on there. So I click on that and it shows all the different programs running on the Pi now, and you can go in and look at all the details. But this is the one that I wrote with the AI that goes to it communicates with the Hawkes Bay and the Rosie on canbus. That's this one. I made it into a container and all that. And here I got Grafana. That's the graphing program for those other batteries. Influx, Mosquitoes, MQTT broker. Pi-hole I use to get rid of ads on my internet. And Portainer CE is this program we're looking at. So a few others. So yeah, it makes life a little bit easier, really. And this shows if they're all running. I wanted to mention one other thing about the using AI, is that I started out with ChatGPT and then I went to Google Gemini, and they both work, but they both have different kind of ways they do it, and you need to steer them, you need to know what to ask them to do, you need to test everything, you need to know when to say go back and do it the other way because it's getting too complicated. And I mean, I spent 2 whole days like things worked and then it went off and it's doing things a different way, and then it wouldn't work. But anyway, one of the things ChatGPT told me, that I had noise on the canbus and I was getting these big numbers like this, and it said, oh, that's from noise on your, like your resistors aren't in the right place, or you're getting some noise in on the cabling or something. So when I went over to the Google Gemini AI, it saw this number. I kind of fed it in what I had done. It saw this number and it said right away that it wasn't noise. It was from what it says here. It's a classic digital null. And it said, it's like when it went to resting at night, it disconnected the PV. Instead of sending 0, it was all ones. So then it goes through and if you looked at the code, it goes through the math to, it divides it by 10. And so that's where that number came from. So it put in a filter to keep it so it wouldn't show that. Whereas ChatGPT had me running around, checking all the cables and stuff because I thought there was noise getting in there. And all along it was just like a code thing. So that was interesting that the one AI spotted it right away. The other one had me barking up the wrong tree. And then here's my project. It's on GitHub. So I synchronize all my code and everything to this GitHub page, which is this. It's called Hawkes Bay Can to MQTT. And, so all the code that I do when I get it finalized, and I have a README file that I, of course, have the AI write, but I modify it as I need. So this explains how all the code works. I got examples of how to make those graphics and stuff. So anyway, yeah, you don't just ask it to do something and then it works. It could do that once in a while, but more often than not, there's errors. You got to feedback the errors. You got to test everything. So AI is good, but it does need human coaching, at least at this point.